one tiny component could plunge a fully loaded airplane from the heavens. Air France Flight 447 demonstrated this chilling reality, an event where 228 lives were lost across 4 nations. The core issue revolved around pitot tubes, those crucial sensors providing essential airspeed data for the pilot controls. These vital instruments became clogged with ice crystals at high altitude, causing erroneous readings that severely confused the flight crew and the onboard computer systems. Investigations later revealed a critical design flaw, making them susceptible to this icing condition, especially in tropical thunderstorm environments. This defect was not unknown in the aviation industry. For many months prior to the incident, there had been several reported incidents of similar pitot tube malfunctions on other aircraft types, involving many dozens of prior flights. There was a clear path to a straightforward solution, perhaps involving a different heater design or an alternative sensor model, costing just a few $100s per aircraft unit to replace. However, this relatively minor upgrade, a simple engineering fix, was overlooked, and its implementation was delayed across the fleet for many months, if not years. Many airlines and manufacturers exhibited a puzzling indifference to these early warning signs, and the cumulative safety data collected over hundreds of thousands of flight hours. The consequences were devastating beyond imagination, causing immense grief to hundreds of families and a profound shock to the global aviation community. The cost of this collective inaction was not merely measured in millions of dollars of aircraft value, or the billions spent on the lengthy multi-year recovery and investigative efforts involving dozens of specialist teams, but primarily in the immeasurable value of human life lost. The disaster forced a reevaluation of pilot training protocols, especially for managing unreliable airspeed indications at high altitudes, where manual flying skills become paramount for many critical minutes. It also highlighted the critical need for better communication channels between airlines, manufacturers, and regulatory bodies regarding safety advisories and technical bulletin implementations affecting thousands of airplanes globally. The incident served as a stark reminder that even with sophisticated modern aircraft systems involving millions of lines of code, the simplest component failure, when unaddressed, can lead to catastrophic outcomes affecting dozens of people and entire operational procedures globally. It took many years and countless hours of dedicated work by many dozens of experts to fully understand the chain of events that unfolded on that fateful night over the Atlantic Ocean. A testament to the complexities of modern air travel and the often ignored lessons of simple engineering that could have saved so many. A mere 3 sensors sealed the fate of 228 people. Air France Flight 447 became a tragic testament to overlooked engineering flaws, an incident where crucial pitot tubes failed catastrophically. These tiny instruments, responsible for airspeed data, became choked with ice crystals at high altitude in specific tropical thunderstorm conditions. The investigations uncovered a critical design vulnerability in certain models like the Tawas AA type, which displayed a truly concerning susceptibility to such icing conditions. Astonishingly, this defect was not an isolated discovery. For many months, even years before the disaster, there had been dozens of documented incidents, some involving multiple near misses of similar pitot tube malfunctions across hundreds of flights on other aircraft types involving many manufacturers. The solution, a straightforward engineering fix, could have cost as little as a few $100s per aircraft unit for replacement, a minor expenditure for such critical safety hardware. This seemingly simple upgrade, however, faced inexplicable delays and was not widely implemented across the global fleet for many months to several years, despite clear warnings and accumulated safety data spanning hundreds of thousands of flight hours. Many airlines and aircraft manufacturers exhibited a puzzling and dangerous indifference to these early warning signs and the growing body of technical advisories. This collective inaction carried devastating consequences, causing immense grief to hundreds of families across 4 different nations and sending profound, lasting shockwaves through the global aviation community. The financial cost of this oversight was staggering, not only in millions of dollars of lost aircraft value, but also in the billions spent on the lengthy multi-year recovery and investigative efforts involving dozens of specialist teams working for many years. But the true immeasurable cost was in the human lives lost. The disaster forced a significant reevaluation of pilot training, especially for managing unreliable airspeed indications at high altitudes where manual flying skills become paramount for many critical minutes in an emergency. It underscored the critical need for improved communication channels between airlines, manufacturers, and regulatory bodies regarding safety advisories and the implementation of technical bulletins affecting thousands of airplanes worldwide. This incident served as a stark reminder that even with highly sophisticated modern aircraft systems involving millions of lines of complex code, the failure of even the simplest component, when unaddressed, can lead to catastrophic outcomes impacting dozens of people and entire operational procedures globally. It took many years and countless hours of dedicated work by many dozens of experts, including the BEA, the French Accident Investigation Bureau, to fully comprehend the intricate chain of events that unfolded on that fateful night over the vast Atlantic Ocean. This tragedy remains a somber testament to the complexities of modern air travel and the often ignored lessons of simple engineering solutions that could have saved so many lives, preventing an unimaginable loss. A tiny $100 part sealed the fate of 228 souls. The Air France Flight 447 catastrophe highlighted a baffling neglect, a systemic failure where obvious dangers were sidestepped for years. This incident was not a sudden freak accident, but a culmination of dozens of ignored warnings spanning many months and years prior, involving hundreds of aircraft types and many manufacturers. The specific Thales AA type pitot tubes proved highly vulnerable to ice crystals at high altitude, particularly in intense tropical thunderstorms, where they would cease providing accurate airspeed data critical for safe flight. A simple engineering replacement costing merely a few $100s per unit could have prevented the entire disaster. Yet, this straightforward upgrade faced inexplicable delays across the global fleet for more than several years, despite overwhelming safety data and hundreds of thousands of accumulated flight hours showing a clear and present danger. Many prominent airlines and multiple aircraft manufacturers displayed a puzzling indifference to these mounting early warning signs. This collective inaction from dozens of major players carried devastating human consequences, inflicting immense grief upon hundreds of families across 4 different nations and sending profound, lasting shockwaves through the global aviation community for many years. The financial toll of this oversight was staggering, easily reaching millions of dollars in lost aircraft value alone, and billions more spent on the lengthy multi-year recovery and extensive investigative efforts involving dozens of specialist teams working tirelessly for many years to piece together the events. This tragedy forced a fundamental reevaluation of pilot training, especially emphasizing manual flying skills from managing unreliable airspeed indications at high altitudes, a critical change impacting thousands of pilots worldwide. It underscored the absolute need for vastly improved communication channels between airlines, manufacturers, and regulatory bodies regarding urgent safety advisories and the implementation of technical bulletins affecting thousands of airplanes globally for many years to come. This incident remains a stark reminder that even with highly sophisticated modern aircraft systems, involving millions of lines of complex code, the failure of even the simplest, least expensive component, when unaddressed, can lead to catastrophic outcomes, impacting dozens of people and entire operational procedures globally. It took many years and countless hours of dedicated work by many dozens of experts, including the BEA, the French Accident Investigation Bureau, to fully comprehend the intricate chain of events that unfolded on that fateful night over the vast Atlantic Ocean, many thousands of miles from land. This tragic event serves as a somber testament to the complexities of modern air travel and the often ignored lessons of simple engineering solutions that could have saved so many lives, preventing an unimaginable loss for many families forever across the entire world.